you don't need me to tell you how there are large parts of the internet which are pretty toxic, and large parts of public debate are pretty toxic. And I think that the more sane people there are who know how to construct arguments and that can defend sanity against insanity, the better. And if some of those people are professional philosophers, then I think that's good.
Welcome, everyone, to today's AMA, where we are very pleased to welcome Professor Michael Potter. He is Professor of Logic in the Philosophy faculty at Cambridge University and a Life Fellow of Fitzwilliam College. His research interest lies mainly in the history of analytic philosophy, particularly Frege, Russell, Wittgenstein, and Ramsey, the philosophy of mathematics, and philosophical logic. His books include The Rise of Analytic Philosophy, from 1879 to 1930, from Frege to Ramsey, Wittgenstein's Notes on Logic, Set Theory and Its Philosophy, Critical Introduction. He has also published a variety of articles and contributed to several collections. Feel free to add anything, but with that, welcome and thanks very much for being here, Professor Michael Potter.
Hello.
Awesome. So I wanted to start off with a couple questions about Wittgenstein and his approach or approaches to mathematics. So I take it that mid and later Wittgenstein, at least, maintained that mathematics was really a human invention. It's essentially syntactical endeavors, not referential. It doesn't refer to things out in the world. And there are certain things about this approach that I find appealing. For one, it doesn't require positing mysterious abstract entities. But these sorts of views aren't without their problems. First of all, do you think my construal of his view, roughly, is fair? And do you think there is a sort of any plausibility to this sort of approach that he took?
Yes, I do think it's fair. And basically, no, I don't think it's plausible, at least in the way that he did it. I think my own view of Wittgenstein's later philosophy of mathematics is that he got into a kind of cul-de-sac which he couldn't get himself out of. And that's the reason why I think ultimately it's unsuccessful. And my own feeling is that probably he himself half realized that. My evidence for that claim is that he originally intended the philosophical investigations to include a significant amount on mathematics, on the philosophy of mathematics, and then in the end it didn't. And I think the reason for that is that he never got the material on philosophy of mathematics into a state that he was happy with. One thing to remember about treating Wittgenstein as a philosopher is, if you go into the philosophy section of the library, you'll find there's the Wittgenstein shelf with all the publications by Wittgenstein, and of course it's important to remember that of those, the Tractatus is a book by Wittgenstein, and the Investigations is because although it was only published posthumously, he left it in a finished state with instructions for it to be published. But the others aren't. All these other books like Remarks on the Foundations of Mathematics, Philosophical Grammar, Philosophical Remarks, Settle, Culture and Value, these are all books produced by his editors after his death from his typescripts, notebooks, and some of them contain selections by the editors, and none of them were authorized by him in the sense of being left in a state where he thought they were finished. The reason I mentioned that is I think that's particularly relevant to his philosophy of mathematics, because Remarks on the Foundations of Mathematics looks as if it's a book by Wittgenstein, and it isn't. It's a collection of extracts from, well, some parts of it are typescripts, but some parts from notebooks. So I think it's always important in looking at his later philosophy of mathematics to recognize that you're not looking at a finished product. But that's all. That was a rather long-winded historical remark. But as to the content of it, I think the way he got into a cul-de-sac was that he tried out a kind of conventionalism about mathematics, which, well, it's controversial exegetically just quite how radical his conventionalism was. But I don't think the reason it's controversial is I don't think he himself resolved that. So I think that there's a difficulty, first of all, about working out what his view ultimately was, but secondly, whatever it was, I don't think it can work, because I don't think conventionalism can work. So that was a long. Did that answer any of your question?
Yeah, actually, and it did, and it also sort of preempted the next question I was going to ask about sort of how serious of a conventionalist you took him to be. I know that Michael Dummett has argued that he has a sort of radical conventionalism.
That's right.
Do you think that's appropriate, or do you think it's kind of not very clear, maybe precisely where his view falls?
I side more with Dummett on how radical his conventionalism was. What Dummett said seemed right, at least in the sense that this is where Wittgenstein's views seem to end up. And then ultimately, the problem with conventionalism about mathematics, I think, is that it can't. Well, first of all, it's got a challenge to explain the applicability of mathematics. Secondly, it's got a challenge to explain the non-triviality of mathematics. So conventionalism about logic looks as if it's at least a moderately plausible view. So the conventionalism about logic says that, for example, the meaning of the word "and" is given by the fact that the rule of "and" introduction applies to it. So this is if you lay out proofs, logical proofs formally, with rules of inference, one of the rules of inference would be from P, Q, you can deduce P and Q. Okay? And one might say, well, that's just what the word "and" means, right? The meaning of the word "and" is just given by the fact that it can be introduced into arguments in that way. And similarly, you might say that the meaning of the word of the material implication, if-then, is given by the fact that if you have an argument from P as an assumption deducing Q, then you can infer P arrow Q, if P then Q, okay? And similarly for the other logical constants. So that's the kind of view that a conventionalist about logic would have. And I think that that's at least a view worth considering, that I think can explain quite a lot about logic. The problem is that if some part of discourse is to be explained just as flowing from a set of conventions, then you expect it to be trivial. You wouldn't expect any substantial knowledge to be able to be produced just by adopting conventions. The problem is that there are these various theorems in logic that show that that mathematics isn't in that sense trivial. Most obviously Gödel's incompleteness theorem, which shows that arithmetic is in a certain sense non-trivial. And Gödel himself certainly thought that the incompleteness theorem could be used to give a refutation of conventionalism.
Yeah, that's great. I mean, a few questions spring to mind. I guess just briefly first, there are some logics also that are incomplete in that sense as well. Do you think that's a serious problem for them on a conventionalist view, or is that not a problem?
Yes, I mean, full second-order logic shares
right.
exactly those kinds of features. First-order logic, not so much, because first-order logic, you can have a complete set of inference rules for it. I mean, I should say, that I'm skating over problems here. I mean, there's a problem for the inference rules that they have to be in harmony with each other. So I mentioned the introduction rule for and, but there's an elimination rule for and, well, two elimination rules, which are kind of symmetrical with the introduction rule, and they're said to be in harmony with it in the sense that the elimination rule for and says if you've got P and Q, then you can deduce P. Similarly, if you've got P and Q, you can deduce Q. And the reason that those rules are in harmony with the introduction rule, which was from P and Q, you can deduce P and Q, is that, well, if you've got P and Q in front of you, how did it get there? It got there by means of an application of the introduction rule, and well, you can just reverse that. So the elimination rules for and are in harmony with the introduction rules. And then the problem is that there are some rules of standard classical logic which are not, in that sense, harmonious. So that's where conventionalism about logic has a kind of weak spot. So I'm not saying conventionalism about logic is just straightforwardly the right thing to think. I'm just saying it's more plausible anyway than conventionalism about mathematics.
Right. Yeah, that's. I mean, a lot of things to talk about there, but I think as a overview, that seems fair enough. So somewhat famously, Ayer had a view of mathematics according to which mathematical truths are all sort of analytic, true in virtue of the sort of linguistic conventions used to express them. First, I guess, do you think this is consistent with Wittgenstein's approach? And second, I mean, do you think this approach also fails for the reasons you've been discussing, or?
I think it does fail for just those reasons. I mean, I don't think Ayer was a radical conventionalist, but I do think that Language, Truth and Logic, where he expressed this view, that's what, 1935? So it's kind of 4 years after the Gödel published Incompleteness Theorem. So one thinks by then Ayer really ought to have been aware. Because Ayer, of course, had visited Vienna and because Language, Truth and Logic is kind of the English language version of Viennese logical positivism. I'd have thought that by 1935, this sort of consequence of Gödel's Incompleteness Theorem was becoming quite well known. I'd have thought, but maybe not. Maybe people were slow at the time. I'm afraid I don't know the details of the history of that, how quickly people saw the consequences. I mean, certainly the place where Gödel himself lays out his view as to why the Incompleteness Theorem refutes conventionalism, that's quite a bit later. That's about 1951, I think, that he wrote up that material. Yes, so sorry to go back to your question. Yeah, I do think that Ayer's view is refuted by that. I mean, so basically, what it leaves is a problem. I mean, I'm not saying I've got the answer to this. I mean, the thing is that the view that the logical positivists took, which Ayer was popularizing in Language, Truth and Logic, is a really attractive view. Their view was there are no synthetic a priori truths, that all truths are either empirical or they're just linguistic, the product of linguistic conventions. And that's that's one of these things. It would be nice if that were so, because it would solve a huge problem in philosophy. Unfortunately, I don't think it is true, but I don't myself have I can't offer you a neat explanation of how, in that case, how synthetic a priori knowledge is possible.
But you are saying that you agree that we have synthetic a priori knowledge?
At least on some understandings of analytic, yes.
Right.
Synthetic just means not analytic. So at least if you interpret analyticity narrowly, then I think we do have synthetic a priori knowledge.
Right. Sorry, did you want to say something more about that?
Yeah. I think for example, I think that I know a priori that there's an external world, but I'm not claiming it's analytic that there's an external world.
Right.
So, we are ranging quite widely now, but I mean, basically, I think that you can refute skepticism about the external world by saying that the terms in which the skeptic puts their objection, those very terms presuppose the external world that they're trying to get you to doubt. That the words they use to phrase their skepticism presuppose that very world. So I think that in that sense, one can know a priori that skepticism is false. That's an example where I think one that might be a kind of base case of an example of synthetic a priori knowledge, and then one could ratchet up. If you thought anything like that was right, you could then ratchet up and find other examples of putative synthetic a priori knowledge. But I do also think that it's plausible that mathematics provides such examples, or essentially for Gödel's reasons.
You sort of suggested there, like essentially Putnam's argument or something.
Exactly.
Like that. Right. Yeah.
The famous brain-Navat argument, which is that if I were a brain-Navat and I wondered, am I a brain-Navat? My words brain and vat wouldn't refer to brains and vats because I wouldn't be in the right kind of relationship to real brains and real vats to be able to refer to them. So it follows that the brain the vat, if it did wonder whether it was a brain the vat, the thought it could express by tokening the sentence, am I a brain the vat? That thought would be false. So if I run that out for myself, I conclude that I'm not a brain in a vat. Now, that's Putnam's version of it, and that's essentially what I'm endorsing here as a strategy that I think does work against global skepticism. It doesn't work against local skepticism. There could be particular pockets of skepticism which might work, but as a global skepticism about the whole external world, I think that's what strikes me as right.
Yeah, of course, there's some sort of related issues about internalism and externalism, and I'm actually going to have a question or two about those in a bit. But I wanted to first, before we move on to related things, ask another thing about conventionalism. And it seems to me like you're not endorsing it, a sort of conventionalism about logic, but you're not ruling it out. It seems to me a view on the table. And of course, famously, some have, Quine among others, argued against conventionalism, getting truth from conventions at all. Like, of course, he has that famous paper, Truth by Convention, and also one addressing Carnap and others. Do you think that we can have truth by convention, or is that something that you're not taking?
Not substantial. I think you can get trivial truths by convention, probably. So when I said it was a position worth considering for logic, I think I doubt whether it would work for the whole of, but it certainly wouldn't work for second order logic. I doubt whether it would work for the whole of first order logic. It might work for some significant fragment of, propositional logic. So I'm not claiming very much for it.
Right.
But I'm just not ruling it out completely as a view. And it seems to me that I think it would be it's reasonably harmless to think that if you adopt certain conventions, then certain other things flow naturally from adopting those conventions. And that's a kind of knowledge, I suppose, but it's a pretty thin kind of knowledge. It's not going to get you very far.
When you say...
So I just mean things like, if you adopt the convention that, I don't know, that the word I refers to the speaker and the word here refers to the location of the speaker and the word now refers to the time of utterance, then you get that I'm here now is true, right?
Right.
That just follows from those conventions. But I'm here now isn't a substantial piece of knowledge because, I could say confidently I'm here now, even if I had absolutely no idea where I was. So it's a kind of empty knowledge that just doesn't get you very far.
But when you say not substantial, is that the same as like what, not analytic, or sorry, not synthetic, I suppose, or something else? Like what exactly do you take that to?
Yeah, exactly. Well, I'm not sure if it's exactly not analytic, but something like that. Yeah. So I'm suggesting that analytic knowledge is a kind of thin kind of knowledge that's not really worth having. If you know that eggs are eggs, what do you know? Well, nothing. That's the kind of empty, uninteresting kind of knowledge. Whereas I think that at least some mathematical knowledge is substantial or interesting or non-trivial or however you want to unpack it. Is genuine knowledge that's worth having. Not Frege's simile was, he said, it's like taking out of a box what you put into it. That's what the trivial analytic kind of stuff does. It doesn't give you anything new, it just rearranges what you've already got.
Right. Yeah, fair enough. So I think we're going to move on to a question from user Shinichi here. If you want to unmute, you can ask a question.
Can I be heard?
Yep.
All right, thank you for doing the AMA. I wanted to ask, I had a couple questions, but I wanted to start off with when people have disputes in foundations. So for instance, when people have debates about whether V equals L, what kind of constraints you want on forcing, like a proper forcing axiom stuff, and all those kinds of disputes people have, certain people are going to appeal to different things to sort of adjudicate those disputes. So people are going to say, well, look, we're just going to have to appeal to sort of pragmatic reasons. If we assume this, then what comes from this is really boring or really tedious, and we're not interested in that. So some sort of maybe if-then-ism. And other people are going to appeal to, well, this is really the fact of the matter. This is true. This is really the correct foundations. This is what we should be doing. And I was curious if you had a view on not necessarily how mathematicians do adjudicate, but how they should adjudicate these sorts of disputes.
Well, we've shot up the level of complexity here. Until now, we were talking about things like arithmetic or logic. Now you're talking about higher set theory, things like V equals L and large cardinal axioms and so on.
Correct.
So I don't think one has to take the same view about those as one does about arithmetic. So I'm a lot happier, a lot more comfortable with something like if-then-ism for higher set theory than I would be for arithmetic. It seems to be, for arithmetic, it just doesn't work, if-then-ism. Roughly because we need to be able to detach the antecedent to the conditional. You know, if-then-ism about arithmetic is the view that when one says 2 + 2 = 4, one just means, well, if there is the natural number structure, then in that structure 2 + 2 = 4. The problem with that view is you want to be able to use 2 + 2 = 4 to infer from I've got 2 apples and 2 oranges to I've got 4 pieces of fruit. And you don't want to conclude if there is a natural number structure, then I've got 4 pieces of fruit. You just want to conclude I've got 4 pieces of fruit, right? So you use arithmetic to get unconditional inferences. Whereas V = L, large cardinal axioms, constructibility, measurable cardinals, all those things. None of those things are used in inferring about the real world. I mean, even the axiom of choice, which is a lot less esoteric than large cardinal axioms, isn't used in ordinary reasoning about the world. It's used to make bits of mathematics more elegant. So if you want to choose your set theory for reasons of interest, reasons of aesthetic appeal, I think probably those are reasons which people have used to select axioms, and those seem to me to be perfectly understandable approaches. So I'm much more flexible in what I'd say about large cardinal axioms than about arithmetic or real analysis, calculus.
Just as a quick follow-up, if it's okay, you were mentioning choice. Do you have any views about people who try to justify choice based on appealing to something like there's variations of the same argument, something like, well, axiom of choice is going to be required in these certain fields of mathematics, so maybe certain things like functional analysis, and those are going to be indispensable to physics, so we should be by extension committed to choice, otherwise we're going to give up these really important things in physics, for instance.
Yeah, I just don't think that works, because I think the versions of these theories that don't assume choice are adequate for almost all purposes in physics. So I think physicists could get by. I mean, it might just be a little trickier. They might have to work a tiny bit harder sometimes, but I'm not aware of bits of physics where you actually really need choice. I mean, the kind of thing is that you use the axiom of choice to prove that every Hilbert space has a complete orthonormal set, okay? And physicists do use Hilbert spaces, and they do want those Hilbert spaces to have complete orthonormal sets in them. The thing is, though, that actually the Hilbert spaces that are really used in physics are separable Hilbert spaces. And the theorem that I just quoted, the version that's limited just to separable Hilbert spaces doesn't require the axiom of choice. So I think you'd find typically that the versions that don't use choice are actually adequate for most purposes. I'm not going to say all, because I'm sure someone will come up with some counterexample to show me that there is somewhere where you really need choice, but I suspect it's very limited. I certainly don't think that there's any time soon we're going to find a case where we can test the axiom of choice by saying, if we assume the axiom of choice, we've got a theory that says this bridge will fall down. If we assume the negation of the axiom of choice, the bridge won't fall down. So we build the bridge, see if it falls down, and find out whether choice was true. It's just not that kind of axiom. It doesn't deliver that kind of results.
Right, thank you.
Awesome. I actually had a sort of follow-up on that first question, which I found the question and your response really interesting. Do you think, I guess I'll put it this way. What do you think sort of explains that difference between how if-then-ism might work in some of the simpler cases like arithmetic, but not in some of the other ones. Is it because those, like arithmetic and such, are tied to, in some way, sort of observations we can or do make, and the others aren't necessarily? Or what do you think that difference is?
I really don't know. I think it's certainly tied to how abstract part of mathematics is. Now, in a sense, all of mathematics is abstract, but there are levels of abstraction which can actually be modeled. I mean, for those of you who know about the iterative conceptionist set, the basic idea is that you can model mathematical reasoning in the theory of sets, and the theory of sets says that sets are built up in a hierarchy where each level in the hierarchy is formed by taking subsets of the previous levels. And then the more abstract the part of mathematics is, the higher you need to go in the hierarchy in order to model it. So the previous question started with the question about large cardinal axioms. Well, large cardinal axioms are basically a way of saying you can go really, really high in this process of abstraction. The large cardinal axioms say that the iterative hierarchy iterates enormously many times into the transfinite. And I suppose the point is that actually the maths that's used by engineers or chemists or economists to produce theories that we apply in the real world, all that maths can be done just using the first 3 or 4 infinite levels in the hierarchy. So you really don't need to iterate these processes transfinitely many times in order to get enough mathematics for applications. I suppose that doesn't really answer your question why. That kind of is an attempt to locate where the problem arises, but why it should be that the real world doesn't require these iterations in order to reason about it, I just don't know, I'm afraid. Sorry.
Yeah, I recognize, of course, it's a very difficult question. Fair enough. But on a related note, I mean, it seems to me at least that in the philosophy of mathematics, authors tend to focus on, primarily on arithmetic, sometimes basic geometry, and occasionally, but not usually, other sorts of mathematics and higher mathematics. Do you think this focus, general focus at least, on arithmetic and sometimes geometry, is a serious detriment to the field? Or do you think that sort of the views developed by considering a narrower range of mathematics good enough as a philosophy of mathematics?
Actually, I think I would challenge your assumption there. I don't think modern philosophy of maths does actually focus on arithmetic to the exclusion of other sorts. There's been a lot of work in the last few decades, I suppose, particularly on the philosophy of set theory. I mean, there's obviously Penelope Maddy and her work on why to believe the axioms, but also fictionalism. I mean, I think that roughly the reasons why I said I think conventionalism is questionable as a philosophy of arithmetic, I think probably, in my view, applies to fictionalism too. So fictionalism being the view that maths is just a set of stories. I don't think that works for arithmetic, but I think as a view of set theory, it's got something good. It's not as straightforwardly wrong about set theory as it is, I think, straightforwardly wrong about arithmetic. But to the extent your assumption is right, to the extent that philosophers do focus on arithmetic, I guess those who do, it's probably just because they don't know enough about the rest of maths to feel confident discussing it. But I still do think that that at any rate, until we've got a philosophy of arithmetic that we're satisfied with, there's a sense in which why deal with the difficult stuff if we can't even deal with the easy stuff? So, and if we haven't yet got a really satisfying account of arithmetic, what hope is there of getting a satisfying account of higher set theory?
Right. Yeah. I mean, that's fair. I mean, I probably should have mentioned set theory as well, but I'm not. I wasn't trying to suggest that. Well, nobody talks about sort of higher maths when it comes to philosophy of mathematics, but I mean, maybe it's not right that there's, but at least seemed to me that there was this tendency to theorize about sort of some of the more basic stuff. And the sort of worry that I had was that, okay, I mean, suppose you're Wittgenstein or whoever, I don't know, or Frege, and you develop your account of arithmetic, and I mean, then you pack it in. It's like you're done. It's a sort of solve the philosophy of mathematics, even though you haven't shown that this generalizes to mathematics generally, because there's other sorts of mathematics than arithmetic or set theory or whatever else.
I think that's absolutely
recognize that concern.
Yeah, I'm sure that that's right. So I would only regard the philosophy of arithmetic as a first stage. Once you've got a satisfying account of that, then move on to the other stuff. But you're quite right that the other stuff's important too, unquestionably.
All right. Let's see. So I believe you've been critical of what's been called Benacerraf's problem as an argument against Platonism or mathematical knowledge. And the argument is roughly that, if mathematical entities are abstract and acausal, and we can gain knowledge of things only by being causally related to them in some way, then we cannot gain knowledge of mathematical entities. And I take it your main issue with this line of reasoning is that second claim, that we can only gain knowledge of things by being causally related to them in some way. Is this right? And do you mind elaborating on this?
Yes, it is right. I suppose you could have predicted, I would say, that from what I said earlier about logical positivism. So I suppose I just don't have the kind of problem with these non-trivial a priori knowledge that the logical positivists had. And I think an instance of this is our knowledge about abstract entities. So, I mean, a short answer would be, yes, so much the worse for the causal theory of knowledge. I suppose another short answer would be that I don't think of our relation to objects as being all as having to use the case of physical objects in front of us as the paradigm that all other cases have to align with. So I'm quite willing to accept that my knowledge that there's a book over there on the table has to come via a causal relationship between me and the book. But it just seems to me that there's a big gap between that and saying that, so all knowledge about any object, whatever, that I might claim to have, has to come via a causal relationship between me and the object about which I claim knowledge. So I think the opponent there owes us some account of why they think all cases should be just like the straightforward object on the other side of the room case.
Yeah, and then they have to deal with least alleged counterexamples. I mean, how do you presumably know that the sun will rise tomorrow, or that some fact about some distant galaxy outside of your light cone is true? I mean, presumably these things could be things that you could know despite not being caused to know by them, and potentially not even being causally related to them at all.
Yes, I would also comment that I think the notion of aboutness is much slipperier than people sometimes think. So, in what sense is the claim that the sun will rise tomorrow about tomorrow's sun? Or the claim about a distant galaxy, is that a claim about the distant galaxy? Well, in some loose sense it is, because it's mentioned in the phrasing of it, but I don't think it's at all trivial to know what a claim is about.
Right, because then we have to talk about things. Yeah, there's general problems of intentionality, and then how does reference work, and all sorts of philosophy of languages. It's all other kind of worms. I did. So on Benacerraf, I don't know if I'm pronouncing that right, but on Benacerraf, there's another notable argument attributed to him, sort of often called Benacerraf's identification problem, against set theoretic Platonism. And roughly, he argues, since there exists an infinite number of ways of identifying the natural numbers with pure sets, no particular set theoretic method can be determined as a sort of true identification or true reduction. And this is taken to refute the project altogether. Do you think this is a good argument, or do you have any thoughts on that?
Yes, I do think it's a good argument against a kind of crude set theoretic reductionism. So I do think that this embedding of arithmetic in set theory and the embedding of other kinds of mathematics in set theory that we were mentioning a few minutes ago, one shouldn't understand that as literal embedding. It doesn't mean that natural numbers or real numbers or whatever really are sets. It's just a relative consistency thing. It just shows that the theory of natural numbers is weaker than the theory of sets. So if the theory of sets is consistent, then the theory of natural numbers is consistent. So if what bothered you was consistency, and in the first half of the 20th century, of course, that was what bothered a lot of people because of the discovery of paradoxes, then those kinds of relative consistency results give you some confidence. They give you genuine information. That's the way to think about the reduction of the theory of real numbers to the theory of sets. It's just a consistency proof. The question what real numbers are or what natural numbers are, well, those are separate questions. So those just don't get answered by the set theoretic reduction. If you then ask, what do I think natural numbers are? Well, that would take me a long time to answer. So I think we better go on to the next question.
No, I mean, that's really fair. I mean, you're saying it would take a long time to answer, but in principle, you do think you have an answer or something that you would defend?
I've got a part of an answer. I'm afraid that's the way philosophy goes. I don't have a complete answer to that or any other interesting philosophical question, I think.
Fair enough. And just one other thing on that identification problem. I take it that some have used this sort of argument as motivations for more like structuralist views. I mean, do you think
yes,
that's a reasonable approach, or something that's?
No. I'd be content with structuralism as an account of things like the theory of groups or the theory of topological spaces I'm not convinced by structuralism as an account of the core structures, natural numbers and real numbers. Basically, for the kind of reason that I was mentioning earlier, that I think it faces the same kind of problems, explaining how structuralism can deliver the unconditional use of reasoning about the structures in reasoning about the world.
Interesting, yeah. So, I mean, how would you? Is there a sort of general label that you'd assign to your own view, or your the sort of partial view that you have, or is that that'd be too committing?
It's a kind of Platonism, yeah.
Right.
But not full. It's a kind of modest, slightly internalized Platonism. So it's Platonism with a kind of a little admixture of some idealism thrown in.
So when you say slightly internalized, you mean like that means they're partially mental in some sort?
I think that it's partly an outgrowth of our attempts to represent the world. Yeah. So that's what makes it, to some extent, idealist. So
Interesting.
If you asked me, is arithmetic mind dependent? It's certainly not dependent on any individual mind. I certainly think that. Is it dependent on there being attempts to represent the world? I think maybe it is, yeah.
Right. Interesting. I mean, one like potential criticism I've heard about these sorts of views is that if our sort of mathematics is dependent on not necessarily human minds, but you know some minds or mental processes generally, and you know those minds are contingent; they might not have existed. There's some times at which they don't exist. Then those things can't seem to account for the sort of timeless, necessary nature of the truths of mathematics. Does that problem make sense to you?
Yeah, I tend to think that that's a kind of a kind of attempt to step outside the boundaries of our scheme of representation to ask, how would things be if we weren't within that scheme? Well, the answer is we are within it, so we're stuck with it. So there are certain kinds of counterfactuals I think in the end you can't make sense of. And I think this is an example. It's actually, we're actually going right. There is a kind of unity to this. It's actually very like the thing we were talking about earlier about skepticism. What would things be like if there was nothing? That's the kind of thing question a skeptic might challenge you with. Well, the answer is I can't make sense of what it would be like if there were nothing. Why not? Because everything I make sense of, I have to make sense of using the mental apparatus I've got. The mental apparatus I've got, as we were saying, presupposes an external world. So I just can't do anything with the kind of counterfactual I've been asked to entertain. And I think that the case you talk about now is similar. So asking, would there be maths if there were no beings in order to represent? Well, I can't really address that question, I think.
Yeah. When you first gave that response, it sounded like a sort of very Wittgensteinian sort of answer. But I wanted to say, intuitively, I think that what would it take for us to describe these counterfactual scenarios? I mean, there's nothing. I mean, I can start listing out the sort of those scenarios would satisfy, not having minds, among other things. Well, and I recognize, of course, that I'm a mind in a world that has minds that is engaging in that thought process. But that doesn't seem to itself prohibit me from sort of thinking about or sort of describing the way a world would be were there to be no such minds.
Oh yes, I'm no problem about that. I can conceive of the universe being such that there's no intelligent life on Earth, and indeed no intelligent life on any planet. But the question you're asking is, well, would there be mathematics in such a wholly dead world? And I suppose I don't understand what kind of possibility I'm being asked about there, because I don't think of maths as either in the world or not, or outside the world in a sense that would be relevant to getting purchase on that. So mathematics is part of the conceptual apparatus with which we can address the world. To that extent, it's. I probably wouldn't say it's mind dependent exactly, but that it's interrelated with the scheme of representation.
Right. I mean, I guess another way to put the worry might be this. We want to say that there was some time prior to which there were no minds, and also at that, at that time or prior to that time, there was a fact of the matter about, say, some certain mathematical proposition like this 1 + 1. It was true at that time that 1 + 1 = 2.
No, sorry to interrupt you, but I just don't think that's the right way of thinking of it. You're thinking of mathematical truths as true always.
Right.
So they're true at times, and they're true at all times. And they're true in all places. If you have that view, then I agree entirely that the kind of doubt that you're expressing is entirely reasonable. I just don't think that's the right way to think about them.
So
it's not that it's always been true that 2 + 2 = 4. 2 + 2 = 4 just isn't tensed at all. The verb of 2 + 2 = 4 is not a present tense verb. It's an untensed verb. It just doesn't have a tense.
Right. Yeah. So it's not the case that. All right, it's not even really a good question to ask then, whether it was the case that 2 + 2 = 4.
Exactly. I think it's just an ill-formed question. The problem is it's so hard to talk about these things because in English we don't have an untensed verb. Our default is to say things that are untensed. You have to use the present tense.
Right. Yeah.
That's just a restriction of English. Ideally, our philosophical version of English would have a separate tense for an untensed variant of all the main verbs. And I think the correct way to understand mathematics is as containing those untensed verbs.
Right. Yeah, that's really interesting. And so if we were to try to construe your view of mathematics, would you say that it's something that's more created, like invented, discovered, or something else, or how would you approach that question?
It's not invented, that basically would be another variant of conventionalism, I think. I think that what scuppers most of such views is that they don't explain the fact we don't have a choice about it. We don't choose that 2 + 2 = 4. We couldn't just decide tomorrow, let's try making 2 + 2 = 5 and see what happens. It wouldn't work. And of course, that's what the pool of Logicism was. Logicism had this wonderful explanation for why there's no choice about 2 + 2 = 4, because Logicism held that it follows from logic, plus the definitions of the words involved. And again, that's one of these views that would have been great if it had worked. Logicism is a brilliant view, except unfortunately, it just doesn't work. Again, roughly for reasons closely connected with Gödel's incompleteness theorem. But sorry, I'm dodging the question. So I'm saying what it isn't. I think mathematics isn't a matter of invention. So in a sense, it's discovery. But in what sense it's discovery? It's not discovery like discovering another planet in the solar system or something like that. I'm not that kind of Platonist about it. The sense in which I'm a Platonist about it is the sense that, well, in some sense, it's something that there's no choice about it, and we discover it.
Yeah,
and it's not true.
Right, and on your sort of somewhat Platonist view, are we causally related to these objects or mathematical entities?
No, we're not causally related to them. Because
they are fully abstract and acausal in that sort of standard, in the standard view.
Well, I might, if I wanted to be pedantic, I might try to resist the word acausal, in the same way that I resisted saying that they're atemporal, that they're timeless. The point is, the notion of causation just doesn't get a grip on that kind of thing. So, people sometimes say they're causally inert, which makes it sound as if they're kind of asleep. They're things that could be causally active if they could be bothered, but they're just lying there doing nothing. And I don't think they're like that.
Yeah, if we're clear though that sometimes that is the implication or is something that might be inferred. But if we're clear though that we don't mean anything like that, we're just saying that they don't engage, and perhaps can't engage in causal relations. Then you wouldn't object to that.
Yeah.
Okay. Fair enough. Yeah. Let's see. I had another question about that, or I was going to jump back to something about. Actually, just from the chat, we had user Kayak who was wondering if you have any thoughts of in-re structuralism. If you're familiar with that.
Yes. I think the distinction is between in-re and anti-rem structuralism. I think anti-rem structuralism has a chance of being right. I think in-re structuralism doesn't have a chance of being right because it depends on the objects in which the structures inhere. And I think that it's important for the way we use mathematics that mathematics shouldn't be, in that sense, dependent on what there happens to be in the world.
Right.
So, for example, if put it crudely, if there happen only to be finitely many objects in the universe, I'm not quite sure what that would mean, but suppose for the sake of argument that does make sense, then there is no in-ray structure of the natural numbers because there aren't enough things in the universe to exemplify it.
Right. But the anti-REM approach isn't determined in some way.
Yeah, so anti-REM says that it's a structure that's distinct from the things. I mean, there's still a problem about how you know that there is that structure, but it's not as bad a problem as for the in-ray structuralist, I think.
Right. There's still this sort of epistemological problem, but at least you get off the ground. When in the other case, it's potentially don't. And also, you mentioned that. Of course, you've been mentioning sort of throughout that you think the Logicism project has failed. But I mean, I take it that there are still some people who take themselves to be working on that sort of project. Do you think there's some outlook for that? I mean, do you think that there's sort of any hope left, and do you think that the field generally shares your sentiment there, or?
Oh no, there's always hope. I mean, it's very difficult to kill a philosophical view stone dead. I mean, there's so-called neo-Fregean logicism, which is the view that arithmetic flows from Hume's principle together with second-order logic. So Hume's principle being that the number of f's equals the number of g's, if and only if the f's and the g's can be put in one-to-one correspondence. And it turns out that Hume's principle, together with second-order logic, is indeed strong enough to deliver arithmetic. That's a version of Logicism, and that's got a lot going for it. It's got problems as well, but then every view in the philosophy of maths has problems. I mean, the most obvious problem it has is it depends on second-order logic, which is a big assumption.
Right, and that would circle us back to the whole point about second-order logic not being complete and so forth. Well, you're talking about first. I had this somewhat big question, I guess, but it's something that worries me a lot when thinking about the sort of our mathematical knowledge. And, since a lot of these discussions focus on sort of the objects and the source of mathematical knowledge, sort of the relation between mathematical knowledge and other sorts of knowledge, but rarely is there a lot of care taken to understand what knowledge is generally, and justification, truth, and so on. Well, first of all, maybe I'm wrong that this is not something that's given a lot of care in the field. But I mean, if it isn't, do you think that this is a serious problem in the philosophy of mathematics, and maybe it would help make developments if we had a clear understanding of what knowledge is, so that we could assess what the distinctively mathematical sort of knowledge was and how we attain it?
The question of what knowledge is certainly is a big, the whole of epistemology is that. So we've certainly got plenty of people investigating what knowledge is. I think the problem is that all the controversies in philosophy of mathematics are in some way related to the question, to what extent should we think of mathematical knowledge as continuous with other kinds of knowledge? I mean, they're all called knowledge, but are they instances of the same thing? So, one obvious case in point is that you mentioned knowing that the sun will rise tomorrow. That's inductive knowledge. It's interesting that we seem very reluctant to use inductive reasoning in mathematics. Why the difference? Because, it's important to remember the principle of induction. Some people seem to think that the principle of induction depends in some way on time or something, that it's that the futures will be like the past. And it isn't. That you can state the principle of induction just as being the principle that you can generalize from known cases to unknown cases.
Right.
And if that's the principle, then you could, in principle, use that in mathematics. So you could test Goldbach's conjecture by computer. You can test every even number one by step by step to see whether it's a sum of two primes, and it has been tested for all even numbers less than about 10 to the power. Is it 10 to the power 10? I think roughly that it's been done now. And every even number up to that very large number turns out to be a sum of two primes. Well, is that evidence that, does that give you any confidence that Goldbach's conjecture is true? If you think it is, then that would be a kind of application of induction. Now, if knowledge in mathematics is just like knowledge in other areas, then one might expect the kinds of methods one uses to find out the truth in maths ought to be continuous with those in other areas. But as is often said, of course, what's distinctive about mathematics is that its method of acquiring knowledge is proof. It's very distinctive that mathematics uses proof as its route to knowledge. Other areas of knowledge just don't share that feature. They don't have that focus on that one route to knowledge. So that's a reason why one might think that mathematical knowledge was just sui generis, was just completely different from other kinds of knowledge.
Yeah, well, I take it that there's several, at least obstacles, to put it one way, that we might face here. One that, look, if mathematical knowledge, to know some mathematical statement requires having some proof for that statement, then it seems like we can't know whatever is like sort of the axioms of mathematics, or anything for which there is no proof. Is that?
Yeah, so there's a regress problem, yeah.
Yeah.
But it's worth noting that mathematicians can suspect that things are true. They can be pretty confident that things are true before they've proved them. Mathematicians work a lot on instinct, and how they explain their instincts is an interesting question, but they do have instincts. They work on problems where they suspect that something's the case, and good mathematicians, their instincts tend to be more reliable than the instincts of bad mathematicians. And that notion of instinct seems to work. It's kind of in parallel, perhaps, with the notion of proof, but it isn't quite the same as the notion of proof.
Right. I mean, I wonder that maybe it's just like the requirements for justification in a sort of mathematical discourse are in some ways higher than in others. Need to have a proof, at least usually, in order to be justified in believing something. Whereas, and that's some sort of mathematical or deductive proof. Whereas in some other domain, I don't know, when we're talking about the sun rising tomorrow, that sort of requirement isn't present. Maybe the inductive generalization is good enough to justify the belief that the sun will rise tomorrow. Is that maybe something like that's going on. The standards of
Um,
justification vary by the domain.
Standards vary, but methods vary too. I mean, I'm trying to think of a good example, but think of cases which aren't mathematical, but which are highly safety critical, for example, where you really need to have really high quality knowledge. So, something like the safety systems on an airplane, where the consequence of an error would be catastrophic. So there are highly elaborate, highly developed mechanisms used for acquiring knowledge in areas like aircraft design, or the software that controls missiles. Where if it's wrong, you launch a missile unintentionally, that kind of thing, where the consequence of failure is catastrophic. So there, you're not going to be any more casual about your standard than in mathematics. In fact, you might well have a higher standard. But nonetheless, so you might use the word proof there, but it wouldn't be mathematical proof. Proving a safety system on an airplane it's a matter of very, very careful checking of lots of things, but it's not in itself mathematical.
Yeah, I mean, I think some might take these sort of observations in support and use them to support a sort of contextualism, epistemic contextualism. I'm not sure if you're familiar, but roughly the whether some attribution of knowledge is true, say that a person knows some mathematical proposition or some fact about the airplane, depends on features of the context in which the attribution is made. And in that airplane safety case, we might consider that like a high stakes case where there's there's some sort of rigorous demonstration is required, or semi-rigorous, and so to truly attribute knowledge to them, that they have to satisfy those criteria. And in the mathematical case, maybe the when we attribute knowledge, they have to have some sort of mathematical proof for it to count as an object of knowledge. But those things are sort of fixed by the context in which the attribution is made. I mean, do you think that this approach has much plausibility to you?
Yes, I think it's worth noting that again, that know is a slippery verb, in that I think it's ambiguous between a usage where it has a connotation of certainty and a usage where it doesn't. And we tend to flip between the two. We ordinarily say we know lots of things, where of course we might be wrong about them. And then you say, but do you know such and such? And if you put the emphasis on no, you suddenly, it starts to sound as if it means, are you absolutely certain of such and such? I'm quite comfortable with the idea that in ordinary usage, the verb know is context sensitive. It's highly context sensitive how much certainty we require for something to count as knowledge. I was only introducing the aircraft case just to make the point that certainty isn't the sole preserve of the mathematician, but it requires certainty in lots of other areas. And I think we get something as close to certainty as makes no difference in lots of other areas, as well as in mathematics.
Right. I mean, presumably in logic as well. I mean, that's kind of a even easier case, I suppose.
But I was also thinking in empirical cases, there are cases where we test empirical things really exhaustively because it matters. So we have a very high degree of confidence some physical system won't fail, for example.
Right. But we are, I take it, being fallibilists about knowledge. You don't, at least in all cases, have to be to know something requires like, we couldn't be wrong about it, or that we must be, in some sense, epistemically certain of its truth to know it at all. I take it that you're not committed to something like that.
Then. Right. Yeah.
All right. Great. So we had another question from the user Shinichi. If you want to unmute, you can ask your question.
Hi. So I wanted to ask something about certain axiomatic approaches to foundations, just mathematics in general, where sort of very roughly the view is going to be something like when we're doing mathematics, we're going to be, or at least we should be, always appealing to some sort of axioms in the background, and then that's just the way we should understand mathematics. And sometimes people broadly classify this as something like formalism, but that can mean many different things, so I won't use that terminology. But I wanted to know your view on this sort of problem that I think was just being discussed a second ago about when we talk about, say, we have some formal system, and someone asks something about some sort of meta logic theorem, so we prove that the system has some sort of, so it's compact, complete, whatever. And someone asks, well, on this view, where are you, sort of what system are you working in? Sort of what's this meta logical system you're working in? People will give various accounts. They'll say we can weaken the system. We can talk about primitive recursive arithmetic, whatever it is. And we can prove these things there. But of course, you can always, as was said, regress the issue back and keep saying, well, where's this? What's the meta logic and so on? And I'm wondering, on this account, what's the answer supposed to be? People who hold this sort of axiomatic account, what are they going to appeal to when you're at some point you just have to stop, right? So I was wondering if you had any thoughts on this.
Yeah, I think what you've just said is a refutation of that view. Very, I couldn't have put it better myself. It basically goes back to Frege, who offered that as a variant of that argument.
Right.
As an argument against formalism. You can't be formalist all the way down, because you can argue about a formal system in a meta language. Well, are you going to be formalist about the meta language? If you are, then go back to the meta language, same problem arises again. So what you just said is part of the reason why I end up being a Platonist. Not because I think Platonism is a view without problems. It's got a lot of problems. So if I could find another view that worked, I'd probably take that instead. Unfortunately, I think the other views don't work. And for example, what you said is why formalism doesn't work.
I see. Thank you. And if I could just a completely other very short question, because I don't know if enough questions were asked about this, and I'm interested in your thought on this. Famously, Wittgenstein responded to the incompleteness theorems, and I don't know. I'm not an expert on this.
Sorry, you cut out for about 5 seconds. Could you just go back 2 sentences? Sorry.
Yeah, sorry. So, can you hear me now?
Yeah, fine. Go ahead.
Yeah. So the question I was going to ask is about Wittgenstein when he responds to the incompleteness theorems, and I think Gödel responds by saying, "Look, you." Lightly put, you don't really understand. You're making like a simple mistake. You don't understand the theorems. And I was wondering if I think a lot of scholars in this field have differing views on whether he really understood the incompleteness theorems, whether he was making a silly mistake, or maybe he was saying something more profound. And I was wondering what your views broadly on this were.
Yeah, sorry, I'm not as much up on that as I should be. I mean, there are a couple of articles by, for example, Gillian Floyd a few years ago on this, and I read her article, but it's a while ago, so I don't think I can reconstruct a detailed view about it now, I'm afraid. So I think I'd rather dodge that question.
All right, no worries. I wanted to actually ask a couple other questions related to sort of analytic philosophy more generally, and of course you've written on sort of some of the history of analytic philosophy. Do you think the talk of the so-called analytic-synthetic divide in philosophy is meaningful? And if so, how would you construe it?
If the question is can I identify an analytic philosopher when I see one? It's very hard to define what analytic philosophy is. So it is one of these concepts where one tends to feel one knows it when one sees it. It's easier to do that than to say what it is that you've seen. I think in the end, I'd probably say that it's mainly just a tradition that has emerged, and that there are a lot of people who share certain methodologies. I mean, it's very hard to find a single claim that all analytic philosophers sign up to, but there are themes that they tend to share. But I think that one of the healthy things about philosophy is that it questions its own foundations while, like Neurath's ship, while it's underway, it's still questioning itself. So I certainly don't think that the analytic approach is the only approach that's worthwhile. I mean, it's the approach that I'm embedded in, but that's not out of a kind of principled objection to other approaches. It's just that's the one that I find uncomfortable in.
Yeah, I mean, fair enough. I mean, a few weeks ago we had as a guest Taylor Carman, who is a scholar of Heidegger and Merleau-Ponty and others, and he on this topic was quite critical of the distinction, especially concerning its usefulness as a when describing like present day philosophy or present day philosophers, and that it like oversimplifies and potentially polarizes the field. I mean, do you think these are reasonable concerns to have?
I think it's a shame when the field gets polarized. I think if one wants to find dualisms, it's easy to find them. So it's easy to find divides, ways of carving up fields. And analytic, non-analytic is one way of carving it up, but Western, non-Western. There are a lot of divides in philosophy. I'd rather there were fewer divides. My attitude to most of the kinds of philosophy I don't practice myself is that I've got nothing against them. It's just that I don't practice them. I mean, most alternative approaches I'm fairly ignorant of because I spend my time trying to get on with the approach that I'm doing myself, which is, I suppose, a kind of narrow-mindedness in the end, but pretty much, I think, an inevitable one. If you want to make progress in one field, you have to limit yourself somehow.
Yeah, so there's some sort of balance that we want to strike there, because part of the worry that I think Professor Carman had was that if you polarize the field a bit in this way, the different traditions become more compartmentalized. They don't engage with other areas of philosophy, and that can be a detriment. There's stuff to learn potentially from engaging with philosophers more generally, but you don't. I mean, does that make sense to you?
Yes, it absolutely does. And I suppose the thing is that there's no perfect answer in that. If you specialize too much, you become narrow-minded, and there's a danger that you don't learn from other ways of approaching the question. But on the other hand, if you go the other direction, it's just far too big a field for anyone to know about all of it. So the danger is you would spread yourself too thinly, and I don't think there's a neat answer to where the sweet spot is on that continuum.
Yeah, this is a Julian Bagini who's made a similar point to this. You don't want to become too much of a generalist if you're trying to answer some very specific questions that requires specializing on some particular topic or field. Let's see here. So what would you say, I guess this is another sort of even more general philosophical question. What do you think the sort of value of philosophy is to you? Why do you think philosophy is a discipline worth doing, in your view?
I suppose I'd ask, worth doing for whom? I mean, I would separate the question of whether it's worth doing it as an undergraduate degree course from whether it's worth doing as a, to be an academic philosopher as a career. I think those are very different questions. I think the justification for philosophy as a degree course is, I suppose, is going to be to some extent dependent on what kind of philosophy is in the course, but certainly if it's the kind of course that we try to offer in Cambridge, I think it's training in critical thinking of a certain kind. And I think that training is quite transferable. It's applicable in almost any sphere of life. So I think that people who've done philosophy at a place like Cambridge are very employable in a very wide range of careers. And certainly the evidence we have is that they then tend to flourish in a very wide range of careers. So I think it's fairly easy to justify philosophy at that level. And obviously, if we're going to offer courses like that, then you need a few people like me to teach them. But I'm not sure that that's the whole of the justification for what I and others like me do. I mean, if one wants to be ruthless about it, you could run undergraduate philosophy courses on fewer staff than we have if you didn't let them spend their time actually thinking about the stuff in between teaching students. So one needs another kind of justification for that. And for that, I think a large part of my defense of philosophy would be to do with the notion that the space of ideas abhors vacuums. So roughly, if there aren't sensible people thinking hard about difficult philosophical problems, then slightly less sensible people will come in and think about them instead, and that might be dangerous.
Oh, that's actually that's an interesting perspective. I really like that.
But you don't need me to tell you how. Right. There are large parts of the internet which are pretty toxic, and large parts of public debate are pretty toxic. And I think that the more sane people there are who know how to construct arguments and that can defend sanity against insanity, the better. And if some of those people are professional philosophers, then I think that's good.
Yeah, yeah, I'm definitely familiar with some of the things you just mentioned. I think, yeah, I mean, I think the point is, I think, 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 the point We're going to wrap up in a few minutes. You do have, I wanted to ask, I think you have a book coming out, or is it at least forthcoming, concerning Wittgenstein's 1916 transformation. Is that something still in the works, or comment on that?
Yes,
project?
that I'm afraid has been in the works for a long time. I wrote a draft of that about more than 5 years ago, and then it's just been sitting there. And I've worked on other projects, for example, the book about the rise of analytic philosophy, which you mentioned at the beginning. And the book about Wittgenstein 1916 has just sat there. I half intended it to be my pandemic project to finish it, and then I didn't. So I might finish it this summer. I'm not promising. I think my
sounds good.
To come out next year, because then it would be the centenary of the publication of the Tractatus, but who knows whether I'll meet that deadline.
So what? Awesome. So what is the general theme of that book? So if you were to sort of briefly state the topic.
Yes, the theme is that the Wittgenstein changed his conception of the Tractatus halfway through writing it. Roughly speaking, in the summer of 1916. So we know that when he started writing it, it was very clearly a book about the structure, the inevitable structure that he thought that any language has to have in order to represent a world. And it was laid out in a framework of six propositions, numbered from 1 to 6, starting with the world is everything that is the case, and leading to proposition 6, which is going to be the end of the book, which told you what the general form, logical form is of any proposition that's to represent a world of facts. So it was very clearly a book in the tradition that you'd expect a pupil of Bertrand Russell at Cambridge who had also become interested through Regress, someone like that would write. And then at some point, after the summer of 1916, he changed the conception. He added the material on ethics and religion, and then the final proposition 7, where often cannot speak, there often should be silent. That's all later editions. So the idea of this book was to try to explain what was going on when Wittgenstein had that change of mind, what motivated him, what was the change of mind, and what were the views about ethics and religion that he wanted to include in the final version that he didn't have in his original conception.
Yeah, that's really interesting. I to be honest, I'd never even known that he had that later edition. That stuff had been a later edition in his writing. I didn't even know that. So that's.
Well, the reason we know that is just that he wrote the book in a big hardback notebook, which is now in the Bodleian Library in Oxford. That hardback notebook, the first page of it lays out the structure of the book, the number of propositions, 1, 2, 3, 4, 5, 6. And then the succeeding pages, he copied in all the other remarks in the book, putting decimal numbers next to them to indicate where they fitted into the structure that was laid out on the first page. And if you look at that hardback notebook, it's just, as I say, page 1 is just numbers 1 to 6, and you look through the succeeding pages to find where do propositions with numbers greater than 6 occur, and the answer is there are no propositions with numbers greater than 6 until about more than 60 pages of the notebook have been filled in. So he compiled a lot of the book while still intending it to end at proposition 6. And so you can see from that physical notebook the order in which he developed parts of the book, and you can see that the stuff's later. And then the stuff where he does add propositions with numbers bigger than 6, he then starts incorporating propositions from his 1916 notebook, which is how we know that this transition must have happened in 1916. Now, the famous thing that happened to him in the summer of 1916, of course, is the Brusilov Offensive, which is this huge battle on the Eastern Front in the First World War, a battle of unimaginable slaughter, with a million men on killed or injured or taken prisoner, colossal numbers of dead and injured. And in June 1916, Wittgenstein was in the thick of it on the Eastern Front. So, indeed, for a month, he didn't write anything in his notebook at all because he was fighting for his life. He was in the middle of a terrible battle, and then he survived it. And then, sometime after that, we have this change in perspective. So, it's natural to ask: was this change in his conception of the book at all related to his experience in the Brusilov Offensive?
Right.
It's not straightforward. It's not trivially related in the sense. It's not that he found religion in 1916, because he was already making religious remarks in his diary before then. So it's not that he wasn't an atheist going into the battle and a theist coming out of it or anything like that. So it's not as straightforward as that. But plainly something happened to him in the summer of 1916. Something quite profound. And it's that I'm trying to explore in this book.
Yeah, very cool. I mean, it's often people don't understand just how interesting Wittgenstein's life was. It was a very interesting character. And I guess we would probably have a very different Tractatus today had that change never happened, whatever its cause was, right?
Oh, there are so many what ifs. I mean, what if he had died in the Brusilov Offensive?
Right.
Then the book that would have been published after the war would have been a shorter book, a very different kind of book. Yes, I mean, he's one of these people about whom you could ask endless what if questions. As you say, he had an extremely interesting life. His biography on its own is one could talk about for hours.
Awesome. So I don't want to keep too much of your time. We're going to wrap up the questions now. Thank you so much for being here, taking our questions, and providing your thoughtful responses. It's been excellent.
Thank you. It's been fun.